Okay, again, in this lesson, we're going to work the previous lesson backwards. We're going to write the equation given different information. Reminder that the standard forms of the equation of the hyperbola at vertex HK is given in the following two forms: the horizontal hyperbola, and then you have your vertical hyperbola. Also reminders, HK, and it says hyperbola at vertex. That should say up here center, because HK is the center of your hyperbola. A in each of the formulas, here you have a squared and here you have a squared. A is the distance from the center to each vertex. I'm going to put vertices since there are two. And then B is going to be the distance from the center to each covertice, or to the covertices. So therefore, let's try some of these. Reminder also that if the x is listed first, it's a horizontal. If the y is listed first, then it is a vertical hyperbola. Horizontal hyperbolas look like this. Vertical hyperbolas look like this. So the first one is going to be a horizontal hyperbola. Here you see the transverse axis. So let's go through each of our pieces. Let me change to a different color here. So your first thing is going to be the center. 1, 2, 3, 4, 2 is the center. So let's go ahead and start with that. It's horizontal, so let's list our x first. So x minus 4 is going to move it right 4. Y minus 2 is going to move it up 2. So there's half of your formula. And really now all you need is a, which is the distance to your vertex. Here your a value is going to be 1. So therefore here you have 1 squared. And then b is going to be the distance to your covertex, which is 3. So therefore your b squared is going to be 9. And that's it. Let's try another one. Again, this is another horizontal. Your center is going to be located at 1, 2, 3, 4, 5, negative 5, 1. It is horizontal, so let's list our x first. So that's going to be x plus 5, moves it left 5. And then y minus 1 is going to move it up 1. The distance from the center to your vertex in either direction is going to be your a value. So that's 2 there. So 2 squared is 4, goes under here. And then the distance from your center to your covertex, which is right here, is going to be your b value, and your b squared goes here. So there is the equation of your hyperbola. Next up, you have a vertical hyperbola, because your transverse axis, which is right here, is a vertical axis. So therefore, your y values are going to be listed first. Let's find our center, which I believe is located here. It's in the middle of your two vertices. So the center is located at 3, negative 3. So y values first. And you've got to be careful, since it's moved down 3. You're going to put a plus 3 on the y. It's backwards from what you would think because the y is listed first. Your center got moved right 3, so you're going to do x minus 3 squared on the x values. Next up, all you need is your a's and b's. The a is the distance from the center to a vertex. Here the distance is 1, 2, 3, 4 boxes. So therefore, that's a vertical distance of 4, so that'd be 4 squared is 16. Notice that's under the y's. And then your b value is the distance to a covertice, which is 1, 2, 3, 4, 5, 6, 7. So 7 squared goes under your x's. Next up, find your center. And you can use your midpoint formula if you want to. It's very easy to look here. Here's going to be your b value, which is 3. This is going to be your a value, which is 1, 2, 3, 4, 5. So there's your a and b values. Since it is a vertical, that's going to be your y values are going to be listed first. The center is located right here, and that's at 1, 2, 3, 4, 5, negative 6, negative 2. Since your y's are listed first, it's moved down 2. So that's going to be a plus 2 on the y's. And it's moved left 6, so that's going to be a plus 6 on the x's. So there's half of your equation. Next up, your a value. A is the distance from the center to a vertex. Since it's 5, then we're going to square the 5 and get 25 under the y's. The b value is 3. We're going to square it and put 9 under the x's. And that's it. Now, next up, what if we're given characteristics? We're not given the actual graphs, which were pretty easy there. Again, we're going to find the center by finding the midpoint of the vertices, co-vertices, or foci. It's always going to be in the middle of any of those. Next up, we're going to use the vertices to find A, co-vertices to find B, and a combination of that and this formula, which is the formula for your foci, to find any missing pieces we need. And then we're going to determine the direction. And then that's going to tell us which equation we're going to use. So let's try this. First off, your vertices. Again, the center of your vertices. Let's find the center of our actual hyperbola by finding the center of our vertices. Add the x's, divide by 2, add the y's, divide by 2. That means that my center is located at 3, -2. Next up, let's determine, is this going to be a horizontal or a vertical hyperbola? The way we're going to do that, 9, -2 and -3, -2 are horizontal from each other. The vertices are horizontal, so that means the hyperbola is going to be a horizontal hyperbola. Okay, next up, let's go ahead and find our A, B, and C values since we know it's going to be horizontal. First off, our A value is the distance from a center to a vertex. Since 3, -2 and 9, -2 is 6 units apart, we can do it that way. Or you can find the distance between your two vertices and just simply half it. That's another way of doing it. The length of the conjugate axis. Now, let me remind you that when you have a hyperbola, again, you've got the box in the middle. This is the transverse axis, and this is the conjugate axis. Your B value is going to be half the distance of your conjugate axis. The distance from here to the outside of that conjugate axis is going to be 14 in this case. So therefore, we've got all the information now that we need. Since it's horizontal, we're going to list our x stuff first. So we're going to have x minus 3 squared. Then we have a minus, and it's going to be y plus 2 squared. That got our parabola to this center, equals 1. The a squared is listed first. So since a is 6, you're going to have 36 there, and b is 14, so b squared would be 196. There is the equation of your hyperbola. Okay, number 6, covertices are located at 3, -9 and 13, -9. 3, -9 and 13, -9 are horizontal of each other. However, those are the covertices. Since the covertices are horizontal, that means that the vertices would be vertical from each other, so therefore this is going to be a vertical hyperbola. The distance between the covertices. Okay, let's do this. Well, let's find the center first. The center of our hyperbola is going to be the middle of these two covertices. Add the x's, divide by 2. Add the y's, divide by 2. So therefore, your covertices are going to be located at -5, -9. Or excuse me, your center is located at -5, -9. Next thing that we're going to do is find the values of A and B. A is the distance from the center to a vertex. B is the distance from the center to a covertex. So the distance from here to either one of these is going to be a value of 8. That is going to be your B value. The transverse axis, again, the transverse axis connects your vertex with your vertex. So therefore, since this has a length of 26, you can half that to find your A value. From the center to a vertex would therefore be 13. So now we're good. We're ready to go. Since it's vertical, your y stuff will be listed first. So you're going to have y. To move it down 9, we're going to do y plus 9. To move it left 5, we're going to do x plus 5. So there's your center, and it's equal 1. The a value is going to be listed first. A is 13, so therefore a squared is 169. Your b value is going to be listed second. So since b is 8, then b squared will be 64, and there is your hyperbola. Next one gives you vertices and covertices. To find the center, first off, let's find the center of either one of these sets of points. Add your x's, divide by 2. Add your y's, divide by 2. Your center is going to be located at -1, -3. Next up, let's determine if it's horizontal or vertical. Since the vertices are 3, and this is the best way of doing it, the vertices are going to tell us which direction it's going to go. It's going to tell us what if our transverse axis is horizontal or vertical. 3, -3 and -5, -3 are horizontal from each other. So therefore, this is going to be a horizontal um, hyperbola. So we got our center. We know which direction it is. Next up, let's find our A and B value. The vertices, the distance between the vertices is going to be, again, the length of the transverse axis. Half of that is your A value. So let's find this distance and then take half of it. The distance from 3, -3 to -5, -3, just worry about the 3 and -5. That distance is 8. So therefore, my A has a value of 4. The distance from -1, 4 to -1, -10 is 14. So therefore, half of that is going to be my V value, which is 7. So now we're good. It's horizontal, so we're listing X first. The center is here, so therefore you have an X plus 1 to move it left 1. It's going to be a minus. You're going to have a Y plus 3. We'll move it down 3. Your A value squared is listed under the first term. Your B value squared is listed under the second term. There is your hyperbola. Okay, number 8. Again, they give us vertices and co-vertices. Let's find our center first. Center is going to be the midpoint of either set. Add your x's, divide by 2, add your y's, and divide by 2. So your center is located at -4, -1. Next up, let's go ahead and find our A and B values. You can it doesn't really matter what order you do these in. Your A value is going to be half the distance between your vertices. Your B value is half the distance between your co-vertices. The distance between this vertex and this vertex is 24, so your A value is 12. The distance from this co-vertex to this co-vertex is going to be 14, so your B value is 7. So now we're set. We do have to figure out if it's a horizontal or vertical. -4, 11, and -4, -13 are vertical of each other, and they are the vertices. If the vertices are vertical, then your whole hyperbola is going to be vertical. So that means your y values are going to be listed first. So here we go. Y, to get it to go to -1, we're going to do y plus 1 squared. Let's go ahead and do our x's next. To get it to go left 4, that's going to be x plus 4 squared. And we can go ahead and put equals 1. Our A squared value is listed first, so that's 144. Our B squared value is listed second, that'll be 49. There is your hyperbola. Number 9, your vertices are listed, and 8, 13, and 8, -13. Let's find our center. It's going to be halfway between the two. Add the x's, divide by 2. Add the y's, divide by 2. That's going to be located at 8, 5. There's your center. Next up, you can figure out if it's horizontal or vertical by looking at your vertices. 8, 13, and 8, -3 are vertical of each other. And since the vertices are vertical, that means your whole hyperbola will be vertical. Next up, your A, B's, and C values. The A values is half the distance between your vertices. So the distance from here to here is 16, so your A value is 8. Now, the B value is not given because we are given foci in this one. So the foci, your C value is half the distance between the two foci. So the distance from this to this is going to be 34, so your C value is 17. In a hyperbola, A squared plus B squared will equal C squared. So let's plug it in to figure out what our B value is. A squared is 64. B squared is unknown. C squared, 17 squared is 289. When you subtract 64, you get 225. So that means our B value would be 15. So now we're set. There's A and B. It's a vertical hyperbola, so therefore your Y values are listed first. So you have Y minus 5 squared minus, and let's go ahead and do our X's, X minus 8 squared equals 1. Your A value is always listed first, so A is 8, so you're going to put 64 under the first. B value is 15, so therefore 225, which is B squared, goes under your X term. Number 10. First off, let's find our center. To find the center again, the middle of our vertices, so add your X's, divide by 2, add your Y's, and divide by 2. So the center is located at 7, -8. We can go ahead and determine if it's a horizontal or vertical by looking at our vertices. The vertices are 10, -8, and 4, -8. So those are horizontal of each other. So therefore, this will be a horizontal hyperbola. Let's see, our A value is going to be half the distance between our vertices. So the distance from here to here is 6, so our A value is going to be 3. Our B value we can't find, but our C value is going to be half the distance between our two vertices. Now, another way of doing that is we could do the distance from our center to one of the foci. The distance from center to foci, look at this 7. When you add 7 plus root 130, that gives you one of the roots, or it gives you one of the foci, and 7 minus root 130 gives you the other foci. So therefore, the distance between the 7 and the foci must be that root 130. So therefore, there's your distance to each foci. And again, you can also take the center and you can find the distance to each of these vertices, and that's another way of finding this A value here. So now that we have A and C, we know the relationship between A, B, and C is A squared plus B squared is equal to C squared. When you square a square root, simply take away the radical, which means that B squared is 121 and B would have to be 11. So now that we've got that, we know our hyperbola is horizontal. Let's go ahead and write the equation. Our x stuff goes first since the hyperbola is horizontal. So x minus 7 squared moves it right 7. Y plus 8 squared would move it down 8 equals 1. A squared goes under the x stuff, so you put a 9 here. B squared, 121, goes under the y stuff. There is the equation of your hyperbola. Okay, number 11. The center is going to be the middle of your co-vertices is one way we can find it here. So the middle of this, add your x's and divide by 2, add your y's and divide by 2. The center is going to be located at 1, -1. The co-vertices now. Co-vertices will tell you if it's horizontal or vertical. 1, 3 and 1, -5 are vertical of each other. However, those are the co-vertices. If the co-vertices are vertical from each other, that means the vertices would be horizontal and your whole hyperbola will be a horizontal hyperbola. Your A value, again, a couple of different ways you can find it. You could find, well, actually, B value, because we're talking about co-vertices. You can either find the distance between your co-vertices and half it, or you can find the distance from the center to one of the co-vertices. That distance is going to be 4. Your C value is the distance from the center to a foci. Anytime you have this 1 plus and minus, this right here is that distance. So therefore, your C value is going to be 2 root 5. And we know that A squared plus B squared is equal to C squared. To square this against square each piece, that'll be 4 times 5, which is 20. Move the 16 over in square root, and that gives you an A value of 2. Since it's horizontal, we're going to list x first. So we have x minus 1 squared, moves it right 1. The y plus 1 squared will move it down 1. Our A value squared goes under the first term. Our B value squared goes under the second term. There is your hyperbola. Number 12, co-vertices. The middle of those two co-vertices is going to give you the center. Add your x's, divide by 2. Add your y's and divide by 2 gives us a center at -2, -3. Our A, B, and C values can be found with these distances. The distance from the center to a co-vertex will be our B. So let's do from here to here, which is a distance of 3, would be our B value. Or you can find the distance between these two and half them. The distance from here to here is going to give us our C value. And since it's -3 and -3 plus and minus root 13, that's a C value of root 13. To find our A value, however, we've got to do A squared plus B squared is equal to C squared. Move the 9 over and square root, and that gives me an A value of 2. So therefore, now let's determine if it's horizontal or vertical, and we're ready to write our equation. Our co-vertices, -5, -3, and 1, -3 are horizontal. So therefore, our vertices will be vertical from each other. So therefore, this is a vertical hyperbola. So we're going to list our y stuff first. Y, and our center is going to be here. So the +3 will move it to the -3 where we need it. The x and a +2 would move it to the -2, which we need. We square the A, put it under the first term, square the B, put it on the second term. There is your hyperbola. Number 13. gives us vertices. The vertices are located at 14, 0 and negative 2, 0. To find the center, again, we're going to add them and divide by 2. 14 and negative 2 is 12 divided by 2. 0 and 0 is 0 divided by 2. So therefore, our center is at 6, 0. Let's see. This time they give us asymptote lines. So this is going to be a little bit trickier to find out where those A's and B's values are. We're going to have to think a little bit deeper into this. We can very easily, though, determine if it's a horizontal or vertical by looking at these vertices. Right 14 up 0, left 2 and up 0. Those are horizontal. Those points are horizontal from each other, so therefore my hyperbola is going to be horizontal. And the only thing left now is what are our A and B values. We're going to have to think through this just a little bit. This is a horizontal hyperbola. And remember the box that we drew in the middle of this horizontal hyperbola. Here was the center. This was our B value, and this was our A value. So therefore, the slope of that asymptote line, again, this was our B value, this was our A value. So therefore, the rise and the run of this asymptote line, it rose B and it run A. So therefore, this is going to be our B over A value. So B over A is going to be 5 over 4. However, don't make this mistake. Because of the last section, or a couple of sections ago, we were talking about ellipses, it would be very easy to say, well, then B is 5 and A is 4, and that's not true. Okay, let's go back to our vertices here. Our A value is half the distance between the two vertices. The distance from here to here is 16, so therefore our A value is actually 8, not 4. So therefore, let's take this A value out and put in an 8. And let's solve this proportion by saying 8 times 5 is 40, divided by 4, gives me a B value of 10. Now, you do have to be careful. This right here is not always going to be B over A. It was B over A because it was a horizontal hyperbola. It's going to be a little bit different for the next one. So let's take our A and B values. It's a horizontal hyperbola, so let's list our x's first. So we have an x, and to move it to 6, that'll be x minus 6 squared. Minus, to move it to 0, that's just going to be plain y squared is equal to 1. Your A squared gets listed first, your B squared gets listed second, and there is your hyperbola. Okay, number 14, you're given the covertices. So the covertices are 1, -1, and 5, -1. So that makes the center going to be the middle of that. That'll be add your x's, 6 divided by 2, add your y's, gives you -2 divided by 2. So the center is going to be located at 3, -1. Next up, let's determine if this is going to be a horizontal or a vertical hyperbola. So the covertices, 1, -1, and 5, -1 are horizontal of each other. So that means the vertices will be vertical of each other. So that means that this is going to be a vertical hyperbola. Since it is a vertical hyperbola, let me again kind of sketch out a graph here just to show you something. Vertical hyperbola looks like this. And again, you have this box in the middle. This is the center. The distance from here to here, from the center to a vertex is your A value. The distance from here over to here is your B value. So therefore let's talk about your asymptote line. Your asymptote line has a slope. Again, this was A and this was B. So therefore, if you take the center here and take this point right here on your asymptote line, the slope is A over B in this case. So therefore, this would be your A over B value. A over B is going to be equal to 1 over 2. Now, or you could do negative A over B is equal to -1 over 2, but you're going to get the same thing. So A over B is 1 over 2. So let's take and figure out what A is and what B is by using this again. The distance, half the distance between your covertices, again, since it's covertices, half the distance will be your B value. The distance from 1, -1 to 5, -1 is 4. So therefore, that means that your B value is half that distance, which is 2. So therefore, since your B value is 2, can I say B is 2 and A is 1? Yes, you can in this case. So it works straight across. So there's your A value and your B value. It's a vertical hyperbola, so we're going to list our Y values first. So we're going to do Y. To move it down 1, we're going to do +1. We're going to do x, and to move it right 3, we're going to do minus 3 equals 1. Your a squared is under the first term. Your b squared is under your second term. There is your hyperbola. Number 15. A reminder also, eccentricity is equal to c over a, so that's a ratio as well. Does that mean c is 5 and a is 4? No, that means that the ratio is 5 to 4. C could be 10 and a could be 8. C could be 15 and a could be 12, so keep that in mind. So first off, our vertices. Let's use them to find our center. Half the distance, add your x's, divide by 2, add your y's, and divide by 2. The center is located at 1, negative 2. Next up, let's use our vertices to find an a value. The distance between the two vertices will be double a. So therefore, the distance from here to here is 8. That's twice a, so therefore my a value must be 4. So again, can I just look and say my a value is 4 and my c value is 5? In this case, yes, you can. So a is 4, c is 5. Let's use that to find our b value. We know that a squared in a hyperbola, a squared plus b squared is c squared. A squared would be 16 plus b squared would be 25. That is a triple. That's going to be a 3, 4, 5 triple. So therefore my b would be 3. So now let's use that to write our equation. We do need to know if it's a horizontal or vertical. So since the vertices, let's see, 5, negative 2 and negative 3, negative 2 is going to be horizontally of each other. So therefore this is a horizontal hyperbola. So our x stuff gets listed first. So that's going to be x minus 1 squared, moves it right 1. Y plus 2 squared, moves it down 2. A squared gets listed under the first term. B squared gets listed under the second term. There is your equation. Number 16. Again, eccentricity is equal to c over a. So does that mean a is 2 and c is root 29? Not necessarily. But let's see if we're going to get something to that effect. Your center. We find the center by finding the center of our foci. We're going to add our x's and divide by 2. We're going to add our y's and divide by 2. And when you add negative 3 plus root 29 and negative 3 minus root 29, the plus and minus root 29s cancel and leaves you with negative 3 and negative 3, which is negative 6. So our center is going to be located at 0, negative 3. Also, let's go ahead and take that same foci and determine, is this going to be a horizontal or vertical hyperbola? The foci lie on the transverse axis. So therefore, if the foci are horizontal, the whole hyperbola is horizontal. If the foci are vertical, then the whole hyperbola is vertical. So 0 and negative 3 plus root 29 and 0 and negative 3 minus root 29 are vertical of each other. So therefore, this is going to be a vertical hyperbola. So that means y is going to be listed first. Now a, b, and c, let's find those. The distance, half the distance between these two foci are going to be, is going to be your c value. Or we could say the distance from the center to the foci is your c value. In either case, the c value is going to be the square root of 29. So do we have this one-to-one relationship here? Yes, we do. C is root 29, so that means that a has to be 2. If you got a different c value, then you would have plugged it in and solved the proportion to find out a. We know that a squared plus b squared equals c squared, so let's plug it into that. A squared plus b squared is equal to c squared, which would be 29. Solve that, and you're going to get b has a value of 5. So now we're ready to write our equation. Vertical, we're going to write our y stuff first. So we're going to do y plus 3 is going to move it down 3 where we need it. Minus, well, we don't need parentheses because we're not moving our x value at all. A squared goes under the first term, b squared goes under the second term, and there is your hyperbola.